Static electricity can accumulate on diesel tanks due to the flow of fuel through hoses and nozzles. This buildup can lead to strong electric shocks. Similar experiences have been reported by others. For example, one truck driver mentioned frequently getting shocked when touching the nozzle after fueling, describing it as a small zap. An equipment user reported a similar issue where the nozzle would give shocks and sometimes even sparked during fueling. A safety manager blog emphasized that static electricity buildup on diesel tanks is a common concern, highlighting the importance of proper grounding and bonding procedures. Several factors contribute to static buildup. Firstly, the friction caused by the flow of fuel through hoses and nozzles generates static electricity. Secondly, hoses and nozzles can act as insulators, preventing the static charges from discharging to the ground. Thirdly, dry conditions and low humidity levels can increase the likelihood of static buildup. Strong static charges can have negative consequences. Firstly, electric shocks can be uncomfortable and distracting. Secondly, in extreme cases, static sparks can ignite flammable vapors. Thirdly, static charges can damage sensitive electronics and fuel gauges and other equipment. To prevent static buildup, various solutions can be implemented. Firstly, grounding involves connecting the tank to a ground rod using a bare copper wire. This provides a path for static charges to discharge to the ground. Secondly, bonding involves connecting the tank hose and nozzle together using metal straps or conductive wires. This ensures that all components are at the same electrical potential. Thirdly, anti-static materials can be used in hoses and nozzles. Fourthly, ionization involves installing ionizers near the fueling area to neutralize static charges in the air. It is important to ensure that all equipment and personnel are properly grounded before fueling. Static electricity built up on diesel tanks is a common issue that can lead to electric shocks, fire hazards, and damaged equipment. By implementing proper grounding and bonding procedures, using anti-static materials, and following proper safety guidelines, the risks associated with static charges can be minimized. Grounding provides a path for static charges to safely discharge into the earth, preventing accumulation and reducing the potential for shocks or sparks. Bonding ensures that all metallic components of the fueling system are at the same electrical potential, eliminating voltage differences that could lead to static discharge. Anti-static materials in hoses and nozzles reduce the generation of static electricity during fuel transfer, further minimizing the risk of buildup. Ionization can neutralize static charges in the surrounding air, reducing the overall static charge in the fueling area. Proper grounding procedures for equipment and personnel ensure that any static charges present are safely dissipated. Regular inspections and maintenance of grounding and bonding connections are essential to ensure their effectiveness. In addition to these measures, it is important to educate personnel about the risks of static electricity and the importance of following safety guidelines. This includes avoiding the use of non-conductive gloves or clothing during fueling, as these can prevent the dissipation of static charges. Personnel should also be trained to recognize the signs of static buildup, such as the sound of crackling electricity or the sensation of a tingling shock. When fueling equipment, it is advisable to touch a grounded metal object before touching the nozzle to discharge any static electricity that may have accumulated on the body. In situations where static buildup is particularly problematic, it may be necessary to consult with a qualified electrician or safety professional to assess the situation and recommend additional measures. This could include installing additional grounding rods, improving bonding connections, or implementing other specialized solutions. It is also important to consider the environmental conditions in the fueling area. Dry conditions and low humidity levels can increase the risk of static buildup, so it may be necessary to implement measures to increase humidity, such as using humidifiers or spraying water in the area. The type of fuel being used can also affect the likelihood of static buildup. Fuels with higher conductivity are less likely to generate static electricity than fuels with lower conductivity. In some cases, it may be possible to use a fuel additive to increase the conductivity of the fuel and reduce the risk of static buildup. It is important to note that static electricity is not the only potential source of ignition in a fueling area. Other potential ignition sources include open flames, sparks from electrical equipment, and hot surfaces. Therefore, it is important to implement comprehensive fire safety measures in fueling areas, including prohibiting smoking, using explosion-proof electrical equipment, and providing adequate ventilation. Regular fire safety inspections should be conducted to identify and address any potential hazards. In the event of a fire, it is important to have a fire extinguisher readily available and to know how to use it properly. Personnel should also be trained on emergency procedures, including how to evacuate the area and contact emergency services. In addition to fire safety, it is also important to consider the potential environmental impact of fueling operations. Fuel spills can contaminate soil and water, so it is important to implement measures to prevent spills and to clean up any spills that do occur promptly. This includes using spill containment equipment, such as drip pans and absorbent pads, and training personnel on spill response procedures. It is also important to comply with all applicable environmental regulations. By implementing these measures, it is possible to minimize the risks associated with fueling operations and to ensure the safety of personnel, equipment, and the environment. Static electricity is a common phenomenon that can pose a significant hazard in certain situations, particularly when flammable materials are present. Understanding the causes of static buildup and implementing appropriate preventive measures is essential for ensuring safety in areas where static electricity is a concern. Firstly, friction is a primary cause of static electricity. When two materials rub against each other, electrons can be transferred from one material to the other, resulting in a buildup or static charge. The amount of static electricity generated depends on the materials involved, the amount of friction, and the humidity of the air. Secondly, induction can also cause static electricity. When a charged object is brought near a conductive material, the charges in the conductive material will redistribute themselves. This can create a static charge on the conductive material, even if it was initially neutral. Thirdly, capacitance can also contribute to static buildup. A capacitor is a device that stores electrical energy. When a conductive object is isolated from ground, it can act as a capacitor and store static charge. Once the causes are well known, there are several ways to prevent static electricity buildup. Firstly, grounding is a simple and effective way to prevent static electricity buildup. Grounding involves connecting a conductive object to the earth, which provides a path for static charges to dissipate. Grounding is particularly important in areas where flammable materials are present, as static sparks can ignite these materials. Secondly, bonding is another way to prevent static electricity buildup. Bonding involves connecting two or more conductive objects together, which ensures that they are at the same electrical potential. This prevents static charges from building up on one object relative to another. Thirdly, humidity can also affect static electricity buildup. High humidity levels can reduce static electricity buildup, as the moisture in the air provides a path for static charges to dissipate. In dry environments, it may be necessary to use humidifiers to increase the humidity and reduce static electricity buildup. Fourthly, anti-static materials can also be used to reduce static electricity buildup. Anti-static materials are designed to prevent the buildup of static charges. These materials are often used in clothing, footwear, and packaging materials. Lastly, ionization can also be used to reduce static electricity buildup. Ionization involves using a device to generate ions in the air. These ions can neutralize static charges on surfaces, preventing static electricity buildup. Static electricity can be a nuisance in many situations, but it can also be a serious hazard. By understanding the causes of static electricity buildup and implementing appropriate preventive measures, it is possible to minimize the risks associated with static electricity. When dealing with diesel tanks, the focus is on fuel transfer operations and the potential for static buildup during the process. The movement of fuel through hoses and nozzles generates friction, leading to the accumulation of static charges. Since diesel fuel is a combustible material, the presence of static electricity poses a fire hazard if a spark occurs in an area with flammable vapors. Grounding the tank provides a direct path for the accumulated static charges to safely discharge into the earth. This prevents the buildup of static potential on the tank itself, minimizing the risk of sparks. Bonding all metallic components, including the tank, hose, and nozzle, ensures that they are at the same electrical potential. This eliminates potential differences that could lead to static discharge between these components. Using anti-static hoses and nozzles further reduces the generation of static electricity during fuel transfer. These materials are designed to minimize friction and prevent charge buildup. Ensuring that all personnel involved in fuel transfer operations are properly grounded reduces the risk of static discharge through their bodies. This can be achieved by wearing conductive footwear or using grounding straps. Regular inspections and maintenance of grounding and bonding connections are essential to ensure their effectiveness. Corrosion or loose connections can compromise the integrity of the grounding and bonding systems, increasing the risk of static discharge. In addition to these preventive measures, it is important to establish and enforce strict safety protocols for fuel transfer operations. This includes prohibiting smoking or the use of open flames in the vicinity of the tank and ensuring adequate ventilation to prevent the accumulation of flammable vapors. Proper training for personnel is also crucial. They should be educated about the hazards of static electricity and the importance of following safety procedures. Regular drills can help reinforce these procedures and ensure that everyone is prepared to respond effectively in the event of an emergency. Furthermore, it is important to consider the specific environmental conditions in which the fuel transfer operations are conducted. Dry conditions and low humidity levels can increase the risk of static buildup, so it may be necessary to take additional precautions in these environments. This could include using humidifiers to increase the humidity level or implementing other specialized static control measures. In some cases, it may be advisable to consult with a qualified safety professional to assess the specific hazards associated with the fuel transfer operations and recommend appropriate safety measures. A comprehensive safety program should be in place to address all potential hazards, including static electricity, and to ensure the safety of personnel and equipment. The program should include regular inspections, maintenance, training, and emergency response procedures. By implementing these measures, it is possible to minimize the risks associated with static electricity and to ensure the safe operation of diesel fuel tanks. Remember, static electricity is an invisible hazard that can have serious consequences. Taking the necessary precautions is essential to protect people and property.